we start the new chapter, platelets and coagulation disorders. Uh, what is the normal hemostatic process? In normal hemostatic process, when a blood vessel is severed or cut, first of all there is small vasoconstriction there. Then a platelet plug is formed, a temporary platelet plug is formed there, and third one, the coagulation occurs and a permanent plug or firm plug is formed which stops bleeding. Like this, if this vessel is cut here, there is little vasoconstriction here to reduce the blood flow, to reduce the blood loss. Then the platelets adhere to this endothelium, current of the endothelium, and then the platelets adhere to one another, and in this way platelets gather and a platelet plug is formed to block the flowing blood. And thirdly, the coagulation occurs. Thirdly, the coagulation occurs and a firm plug is formed which stops bleeding. Where the platelets are formed and how they are formed, well, there is a uh, hemopoietic stem cell in the bone marrow. In the bone marrow, there is a hemopoietic stem cell which matures into a megakaryoblast, a blast cell pertaining to the megakaryocyte series, to the platelet series. And this megakaryoblast matures into a megakaryocyte. Megakaryocyte is a large cell with a large irregular nucleus and a large amount of cytoplasm, and this fragmentation of this cytoplasm occurs, and the fragments we call them platelets, which are uh, specks, anucleus specks of varying sizes. Well, this is a megakaryoblast, large cell with a large nucleus. A blast cell, this is also a megakaryoblast, and this is megakaryocyte, large cell with large irregular nucleus and very large amount of cytoplasm. Fragmentation, of which fragments are formed from this uh, cytoplasm of the megakaryocyte, are fragments of various sizes, and these anuclear specks, they are actually the platelets which on peripheral blood film under the microscope they look like this. These are the red cells, and between the red cells small specks of macrocyte, fragments of macrocyte cytoplasm between the red cells. And similarly, this one, a large aggregate, large cluster of platelets on the peripheral blood film under the microscope. And then comes the clotting mechanism, in which, if you remember from your knowledge of physiology, the clotting cascade. Clotting cascade have an intrinsic pathway, then an extrinsic pathway, and then a common pathway. The intrinsic pathway starts with activation of the coagulation factor 12, the Hagman factor, which is activated by contact with subendothelial collagen. When it is exposed to this coagulation factor, and activated factor 12 activates factor 11, which activates factor 9, and activated factor 9 with the help of activated factor 8, phospholipid and calcium. The factor 10 is activated, then prothrombin is converted to thrombin, and thrombin cleaves enzymatically cleaves the fibrinogen into fibrin threads, fibrin monomers, and the fibrin monomers, a meshwork of fibrin monomers, that is the fibrin threads, is formed, and in the interstices of this mesh of fibrin, the blood cells are entangled in this way. There is a meshwork of these white uh, fibrin threads is formed in the interstices of which the blood cells are entangled, and this is how a clot is formed. So, what is a clot? A clot is just a meshwork of fibrin threads in the interstices of which the red cells are entangled, and this forms a firm plug which stops bleeding from the severed vessel. So, uh, the intrinsic pathway, in intrinsic pathway, first of all, the factor 12 is activated, while on this side, while on the right side, extrinsic pathway, in which factor 7 is activated, and which interactivates with the help of calcium ions, activates factor 8. And then there is the common pathway, in which the end point is the formation of fibrin threads, fibrin monomers. Fibrin clot is formed, which is stabilized with the help of activated factor 13. So in this way, a stabilized fibrin clot is formed, which firmly plugs the severed vessel and stops bleeding. Then about the bleeding disorders, the mechanism of stopping bleeding. Well, the mechanism for stopping bleeding from a severed vessel, from a cut vessel, is very essential for survival of the human beings. Because if this mechanism was not there, a small injury to the tissues, to the blood vessels, may have resulted in loss of very large amount of blood. Normally, the hemostasis have three steps or three phases. First one is, as I told you before, the vasoconstriction occurs, then a platelet plug is formed, and then the coagulation occurs, forming a firm plug like this. The platelet plug, and thirdly the coagulation occurs and a clot is formed. Well, abnormal bleeding. How abnormal bleeding can occur? Well, abnormal bleeding may result from the disorder, abnormality of the vessels, blood vessels. Uh, if the blood vessels are very fragile, very little trauma, very little injury can cause large amount of bleeding. Large amount of bleeding, large amount of bleeding and prolonged bleeding. Secondly, if the platelet deficiency occurs, platelets are reduced in number, or their function is defective. In both of the cases, the platelet plug will not be formed, will not be able to effectively block the severed vessel, and excessive, abnormal, prolonged bleeding can occur. And fourthly, if the coagulation is defective, the a defective clot is formed. The clot is not formed in the proper way. Excessive prolonged bleeding can occur. So, four things can give rise to abnormal, excessive, prolonged bleeding. Firstly, the fragile vessels, increased fragility of the vessels. Secondly, the platelet deficiency. Thirdly, the defective platelet function, that is platelet function defects. And fourthly, the defective coagulation. There are some tests to evaluate bleeding disorders. While discussing abnormal bleeding or bleeding diathesis, we'll be talking about these tests again and again. So we have to understand these tests. The first one is bleeding time. Bleeding time is the time taken by a standardized skin puncture to stop bleeding. That is, for example, if we give a small nick at the ear lobule and we do not do something for stopping the blood, we just observe it and note the time which is taken to stop bleeding from this small cut, stop bleeding automatically. That will be called bleeding time, and the normal bleeding time is 2 to 9 minutes. Actually, the bleeding time is the platelet response to vascular injury. Well, this time will be prolonged. This time will be prolonged when platelets deficiency occurs, platelet number is reduced, or the platelet function is disturbed. The second test, platelet count. We can have a count of platelets. Normal platelet count is 150,000 to 450,000 per microliter. We can write it in this way also, that is 150 to 450 to 10 raised to the power 3 per microliter. The third test is prothrombin time. Prothrombin time, written in brief as PT, it is the time needed to clot plasma by exogenously added thromboplastin and calcium ions, and this time is measured in seconds. Well, what we do is we mix some anticoagulant with the blood sample. We stop clotting of blood, and then we spin this blood in the test tube, and in this way the red cells and the others, they settle down in the bottom, and over it the supernatant is a fluid which we call plasma, and the coagulation tests are done on this plasma, and the time needed to clot this plasma by exogenously added thromboplastin and calcium ions. Well, thromboplastin is a substance which hastens clotting. So we add in a measured volume of this plasma, we add thromboplastin and calcium ions, and the time is noted in seconds, which is needed to clot this plasma. Well, this test, prothrombin time, it evaluates extrinsic coagulation pathway and common pathways. So it is the test of extrinsic and common pathways, and it evaluates factor 5. This test, prothrombin time, evaluates factor 5, factor 7, factor 10, prothrombin, and fibrinogen. So, factor 5, 7, 10, prothrombin, and fibrinogen, their quantity, their function is evaluated by the test prothrombin time. And in the deficiency of these, there is deficiency of factor 5, 7, 10, prothrombin or fibrinogen, the prothrombin time is prolonged. Prothrombin time is prolonged. Number 4 test is activated partial thromboplastin time. Activated partial thromboplastin time, abbreviated as APTT, well, it is the time taken to clot plasma by added thromboplastin, calcium ions, and kaolin. Well, in this test, another thing, kaolin, which is a contact factor, it is added in the plasma, and the time needed to clot plasma is measured, is noted in seconds. Well, this is the test, that is activated partial thromboplastin time, APTT, is the test to evaluate intrinsic and common pathways and in deficiencies of factor 5, factor 8, factor 11, 9, 10, 11, 12, prothrombin and fibrinogen, APTT will be prolonged. So in this way, we can have an idea that whether uh, there is abnormality in the extrinsic pathway or intrinsic pathway. And the fifth test is we can measure the factor level directly. We can measure the factor 5, factor 8, and similarly other factors, their quantity, their level in the blood. And we can also determine whether some anticoagulant against these coagulation factors is circulating in the blood. So, factor and circulating anticoagulant assay is the fifth test. Again, the coagulation cascade, the intrinsic pathway on the left side for intrinsic pathway and extrinsic pathway on the right side. So the PT, prothrombin time, evaluates the extrinsic pathway and the common pathway, while uh, activated partial thromboplastin time, APTT, it evaluates intrinsic pathway and the common pathway. Thank you.